So, it is Sunday morning. I barely made it in. Looks like a few are still doing that as well. Did everybody have a good night?
Yeah.
Everybody take pictures and use them as blackmail sometime in the future? All right. Well, if you did, you should have. Remember that for next year. We're going to kick off this morning with Stephen Erickson. If you've been around on XDA for any period of time, I would say Sterrickson's probably was his, actually Sterrickson was his, it still is, really your XDA forum name. If someone would call him the godfather of theming. He's been on staff in a number of different areas for XDA for a while. He's a retired moderator, but still doing development. Retired senior moderator, that's right. And but he's still doing development, and we're pleased to have him kick off Sunday morning.
All right, so as Jeremy said, my name is Stephen Erickson. I've been on the forum since October of 2008. Pretty much, well, actually, I've been on the forum since 2007 when I had a Windows mobile phone. And then I got the G1 when it pre-released, and since then I started in Android doing themes, and then worked myself up to application development. Today we're going to talk about creating root applications with the RootTools Library. The RootTools Library is an open source library that I created to assist me with executing shell commands from an application. The reason why I created that is because I wanted a reusable component that I could use in all of my applications to always be able to easily execute shell commands. And the ideal way to do this was for me to be able to just write 2 lines of command at the most, at the minimum, to execute a simple command on the device and get a response back from it. So it was designed for creating root applications or assisting with that. And it was designed to provide a consistent and proven way to get access to the shell and to execute commands. So the first steps that you're going to need to do to add the RootTools library to your application is to download it. The main project is on Google Code. You can find it at roottools.googlecode.com, or you can just Google RootTools and it'll be the first link. We also have a backup or a version on GitHub as well, which is maintained by Chris right over here. So you can also pull down the source from there if you want to build it yourself or make modifications to it. So after you download the library, we need to add it to your IDE of choice. For this presentation, we're going to talk about Android Studio and IntelliJ, as those are my default IDE of choice, but we also have instructions on how to add the RootTools library to an Eclipse setup. If you need to do that, it's on the wiki for the RootTools page. So right now, Android is moving towards using the Gradle build system for Android Studio IDE. The Gradle build system is based off of Maven, and this is a screenshot of what you would need to do in order to add the library to your Gradle build system. On the left-hand side, you can see that we have the RootTools jar added to the lights folder. You'll need to add it to this folder so that it can be used throughout your application. And in the right-hand side, you can see this is my build.gradle file, and you need to add a dependency for your project to use the RootTools library. Once you've done that, you'll be able to use RootTools throughout your entire application. If you're just using IntelliJ and you're not using the Gradle build system, the setup is similar. You'll need to open the module settings for your project, which you can get to by right-clicking on your project and going down to the menu item module settings. You'll then need to add the library to the libraries. And again, as before, you'll need to create a dependency on your application for the RootTools library. So normally when you add the library to the libraries folder, it'll automatically ask you if you want to add it to the add it as a dependency for your application. So normally the second step of this will already be done for you. So now that we have the application downloaded and added to your library or to your application, we need to learn how to access the RootTools methods. We have a lot of static methods within the RootTools library. These methods are meant as a convenience for doing common operations, such as getting root access, determining if you have root access, if Sue is available on the phone, if BusyBox is available on the phone, and if you have access to root on the phone. So this is an example of telling whether or not you have root access on the phone. So you simply call RootTools.isAccessGet. Now, something to keep in mind with the static methods within the RootTools library is that they are blocking methods. So you need to make sure that when you're calling these methods, that you're doing so from a thread. You don't call these methods from your main UI thread, or else you run the risk of blocking the main UI thread, which is a bad thing. At the minimum, you'll need to import com.sterickson.roottools.roottools. This will give you access to the main RootTools class, which is the gateway into basically all of the functionality for RootTools. There are more classes within the RootTools library that you can utilize to do specific things, but at the minimum, this is what you need to get started with RootTools. So now that we know how to access the static methods, I'm sure you want to know how to get a shell so that you can send commands to the device of your choosing. Getting the shell is pretty straightforward. If you want to get a root shell, you just need to call the static method getShell, and you have 3 arguments that you can pass in. 2 of them are optional, the first one is required. So the first one is a Boolean value, and you'll set it to true or false depending on whether or not you want to get a root shell. The second argument that you can pass in, which is optional, is the timeout. This is the length of time that the application or that the library will spend trying to open this root shell for you. At this point, I have it set to 20 seconds, which is 20,000 milliseconds. The default is 25 seconds. The third argument is the number of retries. So when you're trying to open a root shell with Android, you usually get the pop-up notification from SuperUser or SuperSue, whichever one the user is using, and you have a certain period of time to grant access to the application. And personally, I know I've missed it a few times, and it goes away. So if that happens and your user didn't grant access to your device quick enough, then you can pass in the retries as 2 or 3, and it'll try a couple of times to get root access to the device before giving up and throwing an exception. To get a non-root shell, if you don't want to execute a command as root, you just need to pass in the same arguments, but this time just pass in false. The third type of shell that you can get is a custom shell. The custom shell allows you to specify the shell that you want to use instead of using the standard SH shell or whichever shell is set by default on the user's device. In order to use this, you have 2 arguments. The first one is required, the second one again is optional. The first one being the path to the shell that you want to open. So, for example, you may want to utilize the bash shell, the born-again shell. You would pass in the path to the born-again shell. Or you may want to use ash, so you would pass in the path to ash, and you could utilize that shell instead of the standard default shell. And the second argument here, again, is the timeout, how long the library will take or give a lot to open up the custom shell. So the next step, now that we have an instance of the shell, is to create a command so that we can execute a set of instructions on the user's device. The base command class has 3 abstract methods that you need to implement in order to create a command and execute. The first of these methods is command output. Command output, very simply, gives you the output of the command that you're executing. So it has 2 arguments that it will pass to you. That's the ID of the command and the line that's being returned to you from the command that you executed. So this will be called multiple times, and each time you'll be given another line from the terminal. The second command that you need to implement is command completed. This also gives you the ID of the command that is just completed, as well as the exit code of the command that is completed. Now, this command is, method or abstract method is called whenever a command completes successfully. So this will only be called when a command executes and there's no error reported by the terminal or the library. The last method that you need to implement is command terminated. This command is, or this method is called whenever a command has been terminated for an unknown reason or because there's been a timeout exception. We'll talk about timeout exceptions in just a bit. This method returns to you again the ID of the command that was terminated and the reason that the command was terminated. The most likely reason is that a timeout exception has been thrown, but you can also, there are times where something may happen within the shell or the process and you'll get an unexpected termination. Constructors. So the command class has three default, actually it has 4 default constructors, but we're going to talk about 3 of them. The first one has 3 arguments: the ID of the command that you're creating, the timeout for the command that you're creating, and the commands themselves. So at the minimum, you need to pass in the ID and the commands. But for this constructor, the timeout is going to specify how long the command has to execute. Since some commands, when you execute them, can hang indefinitely until they're closed, we need to be able to set a cutoff limit so that you basically, when you're creating an application and you execute a command on a user's device and you show a loading screen, that the loading screen doesn't stay there indefinitely, causing the user to be upset with you. The third argument here are the commands that you want to execute. For each individual command, you can specify multiple commands to be executed. The important thing here to note is that when you do this, the commands are not executed. The first one isn't executed and then finishes, and then the second one is executed and finishes. These are all executed at the same time. They're sent all to the shell at the same time. So they will execute very quickly, one after another, without regard to what the previous command did. So you only need to do that when you have a block of instructions that you just want to fire in rapid succession. The second constructor that we have also has 3 arguments: the ID of the command that you're creating, and a Boolean value indicating whether or not you want to enable the internal command handler, and the commands that you want to send. Now, I want to talk about the handler that RootTools uses, and I'll talk about it more and show you a little bit more about it later in my demo application. When you create a command with RootTools and you execute it, RootTools looks to see whether or not you have a looper object associated with the thread that you're executing the command on. If there's a looper object associated with the command or with the thread that you're executing on, then RootTools will use a handler to call your callback methods on the same thread that you executed the command on. This is important because if you're executing a command from the main UI thread or from a thread, you want to use the handler so that your callback methods happen on the main UI thread so that you can do UI work. Without this, then when you call some UI work like showing a toast or updating a progress bar, you're going to get an exception. So by default, the handler should always be enabled. The last constructor is the simplest one. This one, at the minimum, you just need to pass in the ID of the command and the commands to execute. So RootTools also has another class for executing or creating commands. This class is called Command Capture. The nice thing about this is that it has the same 3 constructors that the command class has. And what's nice about this class is that it already implements the 3 abstract methods that the command class requires to be implemented. So by default, it just does some logging of the output of the commands and when they finish. So this is nice if you want to execute a command, but you really might not care about if it completes, or you really might not be expecting an output, so you don't need to implement that. This is also nice if you care about the output, but you don't really care about when it finishes, you just want to get the output from it. So now that we have the shell and we know how to create a command, we want to execute a command. Executing a command is as simple as getting the shell, whether it's a root shell, a non-root shell, or a custom shell, and then adding the command to that shell. So the important thing to notice or to know about this process is that commands are executed on a first in, first out basis. The shell keeps an internal queue of the commands to be executed. So while you may add this command to the shell, it may not be executed right away. There may be a slight delay if you have a queue of commands that are still waiting to be executed. So this will be executed as soon as possible. If this is the first command that you're adding to the shell, then it's going to be executed right away. So I want to go over a little bit with you guys about the life cycle of commands so you understand what's going on in the back end and how the commands are executed, how they're monitored, and what happens at the end of a command. So there are 3 threads within RootTools Library that facilitate executing a command. The first of these threads is the input thread. The input thread's job is simply to take a command that's been added to the queue and to execute it or send it to the shell. Once that's done, the output thread comes into play. The output thread's job is simply to read the output from the commands and to send it back to you. The output thread is responsible for calling the callback method command output and sending you each line that corresponds with the output from the command that you've just executed. The last of these threads, this last thread exists in the command class. Its job is to monitor the execution of the command that's being executed. The purpose of the command monitor thread is to make sure that a command does not take longer to execute than has been determined or set by the default command timeout. So if a command is set for a 20-second timeout, then the command monitor thread will wait for 20 seconds and then it will release and it will check and see whether or not the command is finished. If the command is not finished, then it's going to call the command terminated and it's going to terminate the command. Terminating the command will also result in terminating the shell. So there's an important note in that when you call RootTools.get shell, it's important that you don't hold on to an instance of a shell. The reason is because a command can be terminated for a timeout exception or any other reason resulting in an unexpected termination. And when that happens, the shell is going to be closed. Once the shell is closed, you can't add any commands to it. So if you're holding on to an instance of a shell and it is closed, then you're going to have a closed shell and you're not going to be able to execute any commands, and you're just going to get an exception when you try to add a command to a closed shell. So I recommend always calling RootTools.get shell. If there's an existing shell already open, RootTools will use the shell that is already open. If there's not one open, then RootTools will open one for you. So putting it all together, at the very minimum, this is all you need to execute a command. This is the scenario where you're just executing a command and you're doing a fire and forget. You don't care about the output, you don't care about when it finishes or if it fails, you're just nonchalantly executing a command. So you need to get an instance of a command capture in this case, pass in the ID of the command, which I use as 0, and the command that you want to execute. Then you just need to get an instance of the shell and then add it to the command, add it to the shell, and that's it. This example is an example of instantiating the base command class and implementing the 3 abstract methods. It's pretty much the same as the previous, but in this one you do have to provide implementations for the 3 abstract methods: command output, command terminated, and command completed. So here I'm not doing anything with them, so I could have used the command capture class since I, for some reason, don't care about command output, terminated, or completed. So another option that you have, and that I really recommend and that I do in all my apps, is I create, I extend the command class myself, and I provide a default wrapper for all of my applications that I call shell command. So you have the option to do this, and it basically allows you to still retain the ability to execute a command with 2 lines of code, but still gives you the information you need about when a command completes, when a command terminates, or the output coming from a command. So here we can see that I'm passing in 3 arguments. My instantiation, or my instance of shell command, requires that I pass an instance of an interface that I've created called command callback. This interface will let my activity, if that's the one implementing the interface, know when the command is completed or when output has been retrieved from the command that's being executed. This is my shell command class that I've created. You can see that it extends the command class. It also has a declaration for my interface, command callback. I implemented 2 of the constructors because I didn't need the 3rd one. You can see that the first argument is the interface, command callback. You can see I implemented the 3 abstract methods, and that I'm calling 2 of my methods that exist in my command callback. For command output, I'm calling my command callback.command output, and I'm passing the ID and the line of the response coming back from the command that I've just executed. The second abstract method that I've implemented, command terminated, you can see I'm using a custom object to store information about the command. So I'm using a command result, which allows me to set whether or not the command completed successfully. It has the error, if there is one, which there is one in this example, and it sets the ID of the command, and then calls my interface's command callback method with the object. I'm doing the same exact thing in command completed. The only difference is that I'm setting the exit code because the command is completed successfully. So some talking points to go over before we get into the demo. Commands executed via the shell using git shell are non-blocking. They're asynchronous calls, so you can call them from your main UI thread. They won't block. You need to utilize the callback methods in order to know when your command is completed, when output has been retrieved from your command, and when your command has been terminated. You should, even though the commands executed via the shell are non-blocking, I still recommend that you thread all work using RootTools. And the reason for this is that there's probably going to be many cases where you're going to use the shell and some of the static methods provided by RootTools. If you utilize some of the static methods, those are blocking methods. So generally speaking, when you're doing an operation or a couple of different operations with RootTools Library, you should just be safe and thread all of your work. And I mentioned this before, always use git shell when getting an instance of the shell, because if you hold on to an instance of the shell, you could end up with a closed shell, and then none of your commands will get added or executed because you can't add commands to a closed shell. One thing that I didn't bring up yet was the RootTools log and debug mode. So RootTools has a method called log, which will allow you to log debug information for your application. It provides support for all of the standard Android logs like debug, verbose, info, error. But the benefit to this is that if debug mode is set to false, then none of that information will actually be sent. If debug mode is true, then all that information is sent. So what I do in my applications is I usually provide a toggle button to toggle debug mode on and off, so that when the application is running normally, none of the debug information is being sent to the log pad. But when I need to get debug information from a user, I have them toggle the debug mode switch, and then I get them to give me a log, and I have a ton of information about what's going on with the shell. When debug mode is true and you look at the logcat and you're executing commands, you're going to see a ton of output from the shell. You're going to see every command that was executed. You're going to see information about the shell cleaning up commands. You're going to see information about whether or not the shell completed, whether or not the shell terminated. You're going to see a lot of information. All right, so we're going to go ahead and I'm going to show you the demo application. So this is the demo application that I created for this, and I'm going to show you some examples of the RootTools library being used. The first one is an example of why you should thread all of your work. In this example, I did use a thread, and I utilized some of the RootTools static methods. So when clicking this button, I get the notification to grant root access. I grant it. And then right now, it's blocking the main UI thread. So let's see if I can get an A&R to happen. So I have the A&R, so my user is now very unhappy that they have to wait or close the application. And you can see that this one blocked the UI for 24 seconds. So I think generally the allotted time for blocking the UI thread is 5 seconds. So you have 5 seconds to do an operation on the main UI thread and to release the lock on the main UI thread. That's not a very long time, so that's also why you should always thread all of your work. So we're going to look at the code that I did here. So basically here, I just called one command 1,000 times. So it took it took 24 seconds to execute this command 1,000 times. When this command, specific static method for RootTools was executed, it actually executes a lot more commands underneath to the shell. So in all total, this probably executed 3,000 something commands to the actual shell in the course of 24 seconds. So it's pretty good, it's pretty fast. All right, and we'll go back to our application here. All right, and we'll go ahead and do non-blocking timeout. So in this example, I'm not using a thread here. I'm just calling get shell, and I'm executing a command. Since get shell utilizes an asynchronous method, then it doesn't block. So right now, I'm waiting on my loading dialog to go away. And it's taking a really long time because it's a really long command. All right, and here we got a timeout exception. So my command did not complete. The command didn't complete because it took longer to execute the command, which was a find and then followed by the root directory than I had allowed. So by default, the default timeout for a command is 20 seconds. I raised it to 30 seconds at the start of my application. So whenever you're creating an application with RootTools, I highly recommend that you set a default command timeout. You can do that by accessing the property in RootTools default command timeout and setting it to a value of your choice. So if you're executing commands that you know are going to take a long time, then you should generally set a higher command timeout. So the negative side of setting a higher command timeout is that if you do run into an issue where you have commands that take a long time, or you have a command that actually hangs and causes the shell to execute indefinitely, then it's going to take longer for your user to be notified about that. 30 seconds is a long time to wait on an application that's doing something when it's not really doing anything. So you're staring at a message that's not updating the user on what's going on. 30 seconds is like floating in outer space for eternity. So we're going to take a look at the code for the non-blocking. So here I show my dialog. I'm logging the start time, and then here I create an instance of the command class. And you can see that in my command terminated, I dismiss the dialog, and I show a text, I show a toast indicating that the command has failed. If it had completed, then I would have shown how long it took to complete the command. I would have dismissed the dialog, and I would have shown that the command completed successfully. So let's go ahead and take a look at our third example, the threaded example. So here I created a simple thread and I executed a command, and it executes very quickly. So you can see in the toast, that it keeps showing me some information. And so what I did is in the command output, I just did a toast of all of the output. And in this case, I did another find for system bin. So it's showing me everything that's in system bin right now, pretty much. And this is just an example of the type of output that you would get when executing a command. So if you did ls, then you could use the output from the ls to determine what's going on or what's inside of the current specific directory. You could find out if a file had a symlink, or you could find out the permissions for a specific file. So let's take a look at the threaded. So here, again, I'm showing the progress dialog. I'm logging the time, and then I'm creating a thread. The important thing to note here is that I created a looper object that's associated with the thread that I'm running in. This is important because, as I mentioned, the handler is only used if you have a looper object associated with the thread that you're working in. So for an example, I'm going to take out the association of the looper object, and I'm going to show you guys what would happen if you don't have this, or if you don't set up. And take a moment for it to build and send it to my device. Okay, so we're going to run it again, the threaded. We're going to grant root access. And it's executing, and my application is crashed. And my application is crashed because I don't have a looper object associated with it, and I'm trying to do UI work on the callback methods. So I'll show you that right now. This is my implementation of shell command that I showed you earlier. So on the command output, I'm calling the callback command output, which is implemented in my main activity. And you can see in my callback method that I'm trying to do a toast. And since I'm not doing that on the main UI thread, it's causing the exception. So make sure that if you're going to do UI work in the thread in your callbacks, that you're using the handler. And in order to use the handler, if you're using a thread, you need to associate a looper object with that thread. So in this example, you can see that I'm calling a couple of different methods: get busybox applets, get mounts, get busybox version, is access given, is busybox available, followed by an instantiation of my shell command class, which I am just doing a find system bin, which is showing me all the everything that lives inside of the bin directory. So that concludes our demo. One other thing I want to bring up, which Chris would have more information on, is that RootTools, right now what I've shown you is the beta version of RootTools, which will soon become the stable version. So right now we're at version 3.2 on the beta version and 2.6 on the stable version. Within the 3.2 version, Chris has added the ability to execute Java command as root by utilizing the Dalvik VM. So if you want to find out more about that and actually using, creating Java classes that will actually run as root as opposed to executing root commands in the shell, we can talk more with Chris after the presentation. And that concludes my presentation. Anybody have any questions?
Is it safe to assume that if you want to do something like create a file object in a protected area, you have to do it this way and go through an execution command? Like, there's no way to have Dalvik actually elevate to root permission on the file object?
So there's two ways to handle that. The first would be if you wanted to utilize Dalvik or more specifically Java code to do that, you could utilize the ability that I just mentioned with the making Java run as root. That takes some finagling. There's some steps that you need to do that Chris can explain. As I mentioned, this is just released in the beta version, so I haven't had a chance personally to use it. The second way that you can do this is if you're in a protected area, you could just simply go in with the shell and make the area non-protected anymore. Although running on Jelly Bean, you'll probably have a problem with that because when you run on Jelly Bean in 4.3, when you execute a shell as root, let's say you change the permissions, you mount a directory as read-write, and you change, you decide to add some files, the read-write will only be effective for that root shell because it's in its own namespace. So the Java runs on a separate process, so it won't see that the protected area is mountable as read-write. So if you're trying to work with, like, for example, the data/local, which is where I generally store a lot of stuff, you can do that. All you need to do is create the file there with your application. You can use like DD to do that, or you can use cat to do that. And then cheat modding it to 077 so that your Java application will have access to that file. Then you'd be able to read and write to that file at your heart's content.
My apologies if you covered this and this ran a little late. Have you thought of adding a command to open a shell to a specific user? Like say, we wanted to run Sue radios, we have a shell with a radio user.
You mean to run as a certain user ID?
Yes, sir.
I haven't thought about that. Although I would immediately question why you would want to do that.
Well, I mean, you don't always need to run something through a user. Sometimes it's easier just to deal with. Say, running the shell user. Well, you can do this root too, but you have reasons sometimes.
Right. Yeah. No, we haven't thought about that. But that's something that we can definitely take a look into doing. I can see use cases for that. That's a good suggestion.
I have a question for xda-developers. Since xda-Linux is coming about in 4.3, are you going to handle being able to set contexts that you're able to handle accessing their different parts of the operating system through xda-Linux?
I'm not sure exactly what you mean. I think, are you talking about like what I was mentioning earlier with the namespaces, and that if you mount like system to read write and as a root user, then it's local only to that session that you're in, basically allowing others processes to get access to that same session.
I believe that CyanogenMod is going to start doing everything in forcing, so I wasn't sure if they're going to do some sort of processing on like how things get access to different parts of the system partition.
So I haven't looked into that yet. So whenever they come out with that, well, obviously I need to look into it before they do. But I know with 4.3, there were certain changes that I had to make in order to make sure that the library was compliant with the namespaces. So I would imagine that if that comes around, I mean, I'll definitely follow suit and make sure that it'll work on that area too. Now, I guess this is going to be just specific to CyanogenMod, or?
Yeah, it looks like they started in 4.3. Google wants it to be set to permissive mode, but I think CyanogenMod's trying to up the game by setting it directly to enforcing mode.
Doesn't SuperSU already do that with setting the mount points?
Yeah, I think they're using the namespaces. You're right, now that I remember. So you're just using the namespace binding to be able to access various parts of system.
Correct. So if I think right now if you use super user in 4.3 with my library, it wouldn't work, and that's not really a fault with the library, I don't think, but a fault with I guess super user, because I think that that's more on a SU level. That's more of their job to make sure that everything is executed properly.
All right. Well, thank you very much. Appreciate it.